Record linkage with Coupler, presented by Jeremy Stevens. Coupler addresses the problem of bringing together records from one or more data sets. Let's consider this two data set example where we've got demographic information in one data set with an ID, first name, last name, social security number, and date of birth in one file, and a second file or table has visit information with an ID, a number, a temperature, systolic pressure. In order to link visits to demographics, we need a common variable, so we've added social security number to the visits file, and we can use this for our linkage. Now that we've defined a problem, how do we go about solving it? Well, we could get really good data where we know that the matching variables work. We could have human intervention where we manually link the records between visits and demographics. Or we can automate the process with tailor-made code. We can handwrite the code for each application. Or we can use some generalized software packages. Febril is one, Frill is another, Linking is another. While each of these packages have features that we like and use, none of them do exactly the kind of linkage that we have done with a tailor-made code. So we decided to write a new package that fit with the way that we have been doing linkage. For this new package that we're calling Coupler, we've set several major goals for ourselves. First, everything has to be open source. Coupler itself plus all of the packages, gems, and libraries that we're using need to be available. Second, it needs to be cross-platform. It needs to run under Mac OS X, Linux, and Windows. It needs to be easy to install and easy to use. In addition, it needs to have a low cost of collaboration, encouraging others to modify code, submit new code, modify modules. So what does our coupler look like? Given our goal of using open source tools for building coupler, we've used Java as our runtime environment. We're writing the code for coupler in the modern object-oriented language Ruby, but we're running in JRuby, which is a native Java runtime and interpreter for the Ruby language. SQL is a lightweight database toolkit for Ruby that allows us to link Ruby code to database engines. H2 is a specific database implementation that is lightweight, much like MySQL. We're using that to create embedded databases within Coupler. Sinatra is a framework similar to Ruby on Rails, but much smaller, for quickly creating applications in Ruby with minimal effort. Finally, Mongrel is an open source HTTP library and web server written in Ruby, which allows Coupler to display the user interaction created in Sinatra. Coupler is modular in design. The two major parts are the launcher and the application itself. Launcher is available from our GitHub repository. You can download Coupler Launcher, save it on your desktop. To launch Coupler, we're going to double click on the icon on our desktop, the Coupler Launcher, and we will get the splash screen saying that Coupler is installing. Once it's installed, it will launch the browser, and there will be an icon, a little Coupler icon in the menu bar that has two options, open and quit. So if you don't have a browser open with Coupler, clicking on open will do that. Quit will exit you from the Coupler application, which is running in the background. To re-enable the icon for starting up Coupler, you'd go back and double click on Launcher and it would relaunch, check for any new updates, and start up a browser session with Coupler. So now we're ready to get started. It says to get started, first you need to create a project, which we will do. New project, In this case, we've said we're going to add a resource that is a database for this, and we're going to call this resource demographics, and the table in the database is demographics. Click on submit, and Coupler goes out and looks at the resource and says, okay, yes, I used your connection, I found the table that you wanted, here are the fields that are in the table, and click submit, and it will actually go out and grab the connection to this database. And it says now these are the fields that we have in our demographics resource. Let's add another resource to this. This time we're going to make it a CSV file, and we have to click on choose file, and we went out and found the CSV file that we're using for visits in this. Coupler loaded this, gives us the names that are in the first row, on the header row of the CSV file, guesses at the type of the fields, which we can change, and it displays in the bottom part of the screen the actual data that are in this CSV file, and we can scroll through this and sort the data and take a look at it, make sure that it's loading the data correctly. We clicked submit, and now we actually have our visits resource in this project, and we can select fields. We don't need to use all of them, and we can add transformations, but at this point it says yes, you've got visits resource, and the status is okay. And we're going to apply a transformation that is Fahrenheit to centigrade. In the code for a transformation, this is using Ruby, which is an object-oriented language. So what this says is value, which is the current value in the temp field, and we're going to convert that from Fahrenheit to centigrade. So value minus 32 times 5 divided by 9, all in parentheses. The dot round is applying a method to the object that we created here, and in the result field we're saying, okay, we want to leave temp the way it was, so we're going to put this into a new field, call it temp underscore C, and if we scroll down to the bottom of the field, we can see here's an example of temperature converted. So the temperature was 95 degrees, there's no temp C before, but in after it's now 35 degrees. We click submit, and we've defined this transformation on temperature. We could delete this, but now we need to actually run the transformation. We've defined it, so transform now. And once that's run, we can go back now and we can define another transformation on visits. We want to clean up Social Security number, so we're going to create a new field from SSN. We're going to call it clean underscore SSN. Result type, we will select a string. Our code says this is a case structure, so case on value, so case using SSN. When it's all nines, make it a nil, which is a null field. When it's the regular expression that it's 9 digits, well, that's okay. Convert that to an integer. When it's 3 digits, a dash, 2 digits, a dash, 4 digits, we're going to substitute, replace the dashes with blanks, convert that to an integer, and we'll store that, and we'll store the result as an integer. Again, we'll scroll down on this screen. So the Social Security number for visit ID 2 is 508-06129. It's a good one. Transform is out of date. We've added our clean SSN to the list of transformations, and if we wanted, we could go in here and edit this, add a new transformation, but we can click on transform now, and the transformation is run. So we've got temp C, so we've got our two resources, we've got demographics, and we have visits. And now we're going to create a scenario that tells us what we want to do about linkage. We've got the two resources, and they're highlighted, which means we've selected both of them. So it says we want to do a two-file linkage. Now we need to add matchers. How do we link the demographics and visits? We need a comparison. So the first field is SSN integer, and the second field is SSN. So the first one is in the demographics file, the second one is in the visits file. They have to be equal. We click on add. So now it says SSN int that we created through transformations out of the demographic file needs to be equal to SSN in the visits. We're adding a comparison here. We're going to get temp in centigrade, compare it to the integer of 37 degrees centigrade, so the temperature has to be greater than that. And so now we have our two comparisons. We can click on submit, and we're ready to actually run this comparison. And we get an update that says our linkage is running. Here's the result that said, okay, we've come up with 54 groups where the Social Security numbers match and the temperature was greater than 37 degrees between the demographic file and the visits file. We can look at any one of these groups and see which records match. So in this case, we've got ID 22 matched with visit 34, and as we can see, this is the first of 3 records, and we can scroll through these records to say, okay, did we have, okay, we think the Social Security numbers match, did they match? We can also download the results. And here are the links to Coupler, to the Coupler presentation that's here at Vanderbilt, the GitHub location for Coupler, the GitHub Coupler presentations, and the YouTube presentations. Thank you.